There is no line on any official map that marks the Bermuda Triangle. No warning buoy, no boundary, no coordinates agreed upon by governments or maritime authorities. And yet, for more than a century, this place has existed powerfully in human awareness. Sailors spoke of it in fragments. Pilots mentioned it in after-action reports. Families remembered it through silence. Somewhere in the open waters of the North Atlantic, a reputation formed, not through declaration, but through repetition. The Bermuda Triangle is not a destination. It is a space between destinations. It lies within one of the most heavily traveled maritime corridors on Earth. Cargo ships, naval fleets, commercial airliners, private vessels all pass through these waters as part of routine global movement. This is the first paradox. How can one of the busiest transit zones in modern history also become the world's most famous place of disappearance? If danger were the defining feature, traffic should have avoided it. If mystery were real, patterns should be obvious. But neither is true. Instead, what we find is something far less dramatic and far more unsettling. An open ocean with no physical borders. A region governed not by landmarks, but by currents, weather systems, and human decision-making under uncertainty. The North Atlantic here offers no visual guidance, no coastlines, no mountains, no fixed reference points once land disappears beyond the horizon. To the human mind, this kind of environment is uniquely destabilizing. On land, space is defined by objects. At sea, space is defined by absence. The water stretches outward uninterrupted. The sky mirrors it above. Sound is reduced to wind, engines, and the constant, indifferent movement of waves. Silence becomes a physical presence. In such conditions, small errors feel larger. Time distorts. Orientation becomes fragile. And when something goes wrong, there is often no witness. No debris drifting toward shore, no wreckage discovered by chance, no final signal explaining what happened. Only a record that something departed and never arrived. This absence is where the myth begins. Not with monsters or portals or supernatural forces, but with unanswered space. A place where loss occurs without narrative, where tragedy leaves no visible scar. And And so the question that has followed this region for generations is not a dramatic one. It is a quiet, unresolved question. If this place is not supernatural, why has it resisted explanation for so long? When people speak about the Bermuda Triangle, they often imagine a precise shape, a sharply defined zone, a triangle drawn cleanly across the ocean. In reality, no such boundary exists. What is commonly referred to as the Bermuda Triangle is an informal region, loosely described by 3 points: Miami, Florida, Bermuda Island, Puerto Rico. Between these points lies an expanse of ocean covering approximately 1.1 million square kilometers, an area larger than the combined landmass of France and Germany. But size alone does not explain its reputation. What matters is what lies beneath. Off the coast of Florida, the continental shelf slopes gently, as it does in many parts of the world. But here, that shelf ends abruptly. The seabed does not descend gradually, it collapses. Within a short horizontal distance, depth increases from a few hundred meters to more than 6,000 meters. This drop leads into some of the deepest parts of the Atlantic Ocean, including regions connected to the Puerto Rico Trench. From the surface, nothing appears unusual. The sea looks calm, uniform, deceptively simple. But beneath it lies a complex three-dimensional landscape of steep escarpments, underwater canyons, and fractured geological structures. This matters because accidents at sea do not behave the same way in deep water as they do near coastlines. When a vessel sinks in shallow regions, debris often resurfaces, wreckage drifts, oil spreads, evidence returns. Here, that process is interrupted. A ship breaking apart above a sudden depth transition can fall vertically rather than horizontally. Heavy components descend rapidly. Lighter debris is pulled into deep water circulation before it ever reaches the surface. The result is disappearance without trace. The geography does not preserve stories, it erases them. Layered over this terrain is one of the most powerful oceanic forces on Earth. The Gulf Stream. This current flows directly through the region, transporting warm water from the Gulf of Mexico toward the North Atlantic. In places, it exceeds 2 meters per second, faster than an Olympic swimmer. Anything floating within it does not linger. Debris can be carried hundreds of kilometers in days. This creates a second illusion. Even when wreckage does surface, it rarely appears where the accident occurred. Search zones expand rapidly, probability collapses, and as time passes, absence begins to feel intentional. What looks like mystery is often motion. What feels like concealment is displacement. The Bermuda Triangle is not geographically unique in being dangerous, but it is uniquely effective at removing evidence. And when geography removes evidence consistently, human imagination fills the gap. To understand why so many incidents cluster in this region, we need to step away from the ocean itself and look at the traffic above it. During the 19th and early 20th centuries, the North Atlantic was the economic spine of the modern world. Steam replaced sail. Steel replaced wood. Global trade accelerated faster than maritime safety could adapt. By the early 1900s, an estimated 40% of all shipping routes between the United States and Europe passed through or near the region now associated with the Bermuda Triangle. This was not coincidence, it was efficiency. The Gulf Stream shortened travel times. Florida, offered deep ports. The Caribbean connected North and South American trade. As a result, this region became saturated with movement. Merchant ships carrying coal, grain, and iron ore, passenger liners transporting thousands across the Atlantic, naval vessels moving between strategic bases. And later, during the First and Second World Wars, military traffic intensified dramatically. Convoys moved under radio silence. Lights were blacked out. Navigation errors became harder to correct. Increased traffic does not just increase opportunity, it multiplies risk. Every ship is a complex system: human judgment, mechanical reliability, weather interpretation, navigation accuracy. When thousands of such systems pass repeatedly through the same corridor, failure becomes statistically inevitable. Not because the ocean is hostile, but because probability accumulates. A single storm passing through an empty sea leaves no history. The same storm intersecting dozens of vessels creates legend. And this is where perception begins to diverge from reality. Accidents in low traffic regions are isolated. They feel rare. They are quickly forgotten. Accidents in high traffic corridors stack on top of one another. They overlap in memory. They form patterns where none were designed. In the Bermuda Triangle region, loss did not occur in silence. It occurred repeatedly, across decades, under different flags, in different conditions. Passenger ships vanished without distress signals. Cargo vessels failed to arrive without explanation. Naval vessels were listed as overdue, then reclassified as lost. Each incident alone might have been explainable. Together, they created a narrative vacuum. And into that vacuum, mystery flowed. What rarely gets emphasized is this: when traffic density increases, reporting increases. When reporting increases, MIF has more raw material to work with. The triangle did not earn its reputation because it was uniquely lethal. It earned it because it was uniquely busy. The ocean here did not claim more ships than elsewhere. It simply had more ships to claim. And as records accumulated, the difference between correlation and causation slowly disappeared. By the mid-20th century, the stage was set. The region had geography that erased evidence, traffic density that amplified loss, and a public ready to believe that repetition meant intention. All that remained was a single incident, powerful enough to crystallize the myth. That incident would arrive from the sky. On the afternoon of December 5, 1945, 5 U.S. Navy training aircraft lifted off from Naval Air Station Fort Lauderdale. They were TBM Avenger torpedo bombers, designed for war, not for navigation training. The mission was routine: a triangular flight path, bombing practice over shallow water, then a return to base. The irony would become permanent. The squadron consisted of 5 aircraft, with 14 men on board in total. Their leader, Lieutenant Charles Taylor, was an experienced combat pilot, but experience does not guarantee clarity. Within 2 hours, confusion began to emerge. Taylor reported that his compasses were malfunctioning, but later investigation revealed a crucial detail. Not all compasses failed. Different aircraft reported different headings. This was not a system-wide magnetic anomaly. It was disagreement, not distortion. Flight 19 had entered an area where the Bahamian Islands create visual ambiguity. Watercolor shifts, reefs mimic coastline, cloud cover flattens depth perception. Taylor believed the flight was over the Florida Keys. In reality, they were over the Bahamas. That single misidentification inverted every decision that followed. Instead of flying west toward land, Taylor ordered the squadron to fly northeast, away from safety, and deeper into open ocean. Radio transcripts show increasing stress. Pilots questioned the heading. Fuel concerns were raised. Time was running out. The Avenger had a practical flight endurance of approximately 5 hours. By late afternoon, several aircraft were approaching fuel exhaustion. Weather conditions deteriorated, not violently, but subtly. Winds increased, cloud ceilings lowered, sunlight faded. At sea, ambiguity grows faster than fear. At approximately 7 p.m., the final transmission was received. Then, silence. Later that evening, a PBM Mariner rescue aircraft was dispatched to search for Flight 19. It never returned. This second loss became inseparable from the first, doubling the mystery. But the Mariner carried a known risk. It had a documented history of fuel vapor explosions. Witnesses aboard nearby ships reported seeing a fireball on the horizon shortly after takeoff. Two incidents, two explanations, one story. In the decades that followed, the narrative hardened. Compasses failed, planes vanished, the sky swallowed them whole. But modern analysis tells a different story. Human factors dominated every phase. Spatial disorientation, authority bias, stress-induced decision rigidity. No wreckage was ever found, but the search area exceeded hundreds of thousands of square kilometers. In deep ocean, absence is not evidence, it is expectation. Flight 19 did not disappear because the region was supernatural. It disappeared because navigation failed, fuel ran out, and the ocean does not preserve mistakes. What made this case legendary was not what happened, it was when it happened. Just weeks after World War II ended, at a moment when the public expected peace and encountered loss instead. Flight 19 became the first modern myth of the Bermuda Triangle, not because it defied explanation, but because explanation arrived too late. The ocean does not erase evidence out of malice. It erases it through motion. In the Bermuda Triangle region, that motion is constant, layered, and extraordinarily powerful. At the surface flows the Gulf Stream, one of the fastest and most energetic ocean currents on Earth. Its speed regularly exceeds 2 meters per second, faster than an Olympic swimmer can sustain. flow, the Gulf Stream transports more than 30 million cubic meters of water every second. That is roughly 100 times the combined flow of all Earth's rivers. Any object entering this current, wood, metal, fuel, or human remains, is no longer stationary. It is extracted. Debris can be carried hundreds of kilometers in days, dispersed across vast areas of open ocean. Search patterns fail not because investigators are careless, but because the target no longer exists as a single location. Beneath the surface, forces intensify. The seafloor here drops abruptly from the continental shelf into deep ocean trenches and fracture zones. Depths increase from 200 meters to over 6,000 meters in distances shorter than a commercial flight runway. Once debris descends beyond light penetration, recovery becomes nearly impossible. Pressure increases 1 atmosphere every 10 meters. At 4,000 meters, pressure exceeds 400 times that at sea level. Air-filled structures collapse instantly. Materials fragment. Identifiable shapes are destroyed. But perhaps the most underestimated force here is the wave itself. Not storms, not hurricanes, rogue waves. These waves form without warning, often through the interaction of currents and wind patterns. In regions like the Gulf Stream, they can exceed 20 meters in height, rising vertically from relatively calm seas. For a ship, this is not impact, it is inversion. The hull is lifted beyond design tolerance, then dropped into a void. Structural failure follows. No distress call, no time. Submarines and aircraft face a different threat. Sudden atmospheric changes over warm currents create violent convection, downbursts, microbursts. Aircraft entering these zones can experience rapid altitude loss and spatial disorientation. Before modern instrumentation, pilots had seconds to react. After impact, the same oceanic processes apply. Currents scatter wreckage, depth consumes what sinks, time degrades what remains. What investigators often find is not absence, it is over-dispersal. The ocean does not preserve narratives, it dismantles them. And when nothing returns to the surface, humans do what they always do. They assume intention where there is only force. In the Bermuda Triangle, nature does not hide the truth, it simply refuses to keep it intact. For decades, the Bermuda Triangle was described as a place where compasses spin, navigation systems fail, and direction itself becomes unreliable. This idea sounds compelling, but it is also deeply misunderstood. The Earth does not have a fixed magnetic north. Magnetic north moves. It drifts by tens of kilometers every year due to fluid motion within the planet's outer core. Because of this, the direction indicated by a compass is never identical to true geographic north. The difference between them is called magnetic declination. In most parts of the world, declination is small and stable. But in certain regions, including the western North Atlantic, declination shifts rapidly over distance and time. 20th century, navigational charts required constant updates. Many ships and aircraft did not have them. Before satellite navigation, pilots and captains relied on printed maps, dead reckoning, and magnetic readings. If a chart was outdated by even a few degrees, the error compounded. Over hours, a vessel could drift dozens of kilometers off course without realizing it. This is where the myth begins. The Bermuda Triangle was once described as a location where magnetic north and true north align. This alignment did occur, but it was temporary. It migrated and eventually left the region entirely. There was nothing unique or dangerous about it. Yet books continued to repeat the claim long after it ceased to be accurate. Navigational failures that occurred in the region were later reinterpreted through this mythic lens. A compass reading that disagreed with expectation became evidence of anomaly rather than outdated data. With the introduction of GPS in the 1990s, the narrative changed. Satellites do not rely on magnetic fields. They calculate position through time and geometry. As GPS adoption became universal, reports of mysterious navigational failure declined sharply. Not gradually, abruptly. Accident rates fell. Unexplained deviations disappeared. The ocean did not change. The tools did. What this reveals is uncomfortable. The Bermuda Triangle was never a place where physics broke. It was a place where human understanding lagged behind reality. The myth survived not because it was accurate, but because it was useful. It explained error without assigning blame. It transformed miscalculation into mystery. And mystery is easier to accept than failure. When stories dominate a subject long enough, numbers become the only reliable counterweight. For the Bermuda Triangle, those numbers exist. They have existed for decades. Major maritime insurers, including Lloyd's of London, have tracked global shipping losses since the 18th century. Their assessments are not driven by curiosity, but by risk. Insurance does not care about legend, it cares about probability. According to Lloyd's records, the rate of ship loss in the Bermuda Triangle region is statistically consistent with other heavily trafficked ocean corridors. No anomaly, no spike, no unexplained deviation. The same conclusion appears in reports from the U.S. Coast Guard. Despite thousands of annual transits through the region, Bermuda has never been designated a high-risk zone for commercial shipping. It does not appear on restricted navigation lists. It does not require special insurance premiums. If vessels were disappearing at unusual rates, this would not be subtle. Insurance markets respond faster than myth. A ship lost in the South China Sea, the North Sea, or the Gulf of Mexico is processed through the same analytical framework. The triangle fails to stand out. Even aviation data supports this. Commercial flight routes over the region operate under standard safety classifications. No elevated incident rates, no unexplained losses in the modern era. What does spike is reporting. Books published in the mid-20th century selectively grouped incidents across decades, removed context, and presented them as clustered events. Timelines were compressed, distances were ignored, weather data was excluded. This technique did not falsify individual cases, it reframed them. Once framed as a pattern, confirmation bias did the rest. Every accident became proof. Every absence of evidence became further mystery. The public rarely saw the denominator. How many ships passed safely? How many flights arrived without issue? Without context, rarity feels common. By the late 20th century, data quietly closed the case. But the story did not end. Because numbers resolve risk, they do not resolve fascination. By the end of the 20th century, the Bermuda Triangle had been explained. Not in a single moment, not through revelation, but through accumulation. Better maps, better instruments, better understanding of ocean dynamics. The mysteries did not vanish, they were resolved. And yet, the story endured, because the ocean does not give closure. When a plane crashes on land, there is wreckage, there are reports, there is accountability. At sea, there is often only absence, no witnesses, no remains, no final signal. For the human mind, absence is unbearable. We fill it with meaning. The Bermuda Triangle became a narrative solution to a psychological problem. It allowed loss without explanation, tragedy without fault, a place to project uncertainty in a world increasingly mapped and measured. But the truth is quieter. The ocean does not need myths to be dangerous. It is dangerous by scale alone. It erases not because it intends to, but because it is vast, dynamic, and indifferent. The triangle does not hide answers. It reminds us of something older and less comfortable. That human systems are fragile, that technology fails, that evidence is a luxury the sea rarely returns. In the end, the Bermuda Triangle is not a mystery of geography. It is a mirror, reflecting our discomfort with uncertainty, our need for stories, and our reluctance to accept that sometimes there is nothing to explain, only forces, motion, and time, and an ocean that moves on, unaware of the legends we leave behind.